Selamat sejahtera Doktor. We're going to explain Lab 4 RC and RL low pass filter stimulations using the multisim software. So firstly, we're going to do the part 1 is RC low pass filter. We're going to construct the figure 2, the RC low pass filter. To the first So these are the circuit, the figure 2. So firstly, according to the procedure, we're going to set the frequency, starting frequency is 100, and then the amplitude is 2 dB. Then we're going to connect the oscilloscope. Channel 1 is connected to the V voltage input. Channel 2 is connected across the capacitor. To differentiate the two channels, I'm going to change the channel A's wire color to blue. So we're going to run the stimulation. Single. So to find the V out, for V out is actually the voltage across the capacitor. So channel B. Firstly, we take the channel B, put to the peak of the wave B. Wave B is to represent the red color wave. So the maximum, the voltage for the when the frequency is 100 is 1.987 volt V out, and for the V in is the channel A. So we're going to see what is the so for the maximum V in is 1.997 volt. To find the V out, so for the frequency when the frequency is 100, the V out is 1.987 volt. So to find the phase difference, the phase shift or the phase angle, we will use we need the formula, we need the change in the time. So the time difference between the two waves are 10.038 milliseconds. So So these are the readings we obtain. As the frequency increases from 10, 100 until 10 Ks, these are the V out we obtain the readings, and also the phase angle we calculated by using the formula where the change in the time divided by the period times by 360 degrees. So then for the AV we use the formula V out over V in, and then AV decibels one we use this formula to calculate. So that's for the part 1. Now we proceed for part 2. Part 2 is RL low pass filter. We're going to construct the circuit, the figure 3 circuit, RL low pass filter now. So for inductor is 3 milli. round. So these are the figure 3. Firstly, we set as the procedure, we set the frequency is 100 and VP amplitude is 2 VP. Then we connect the oscilloscope, the channel um, V in, V in, voltage in, channel A, channel B is across the resistor. We connect. We're going to change the color of the V in, channel A to blue. So we can run. Change the scale so that we can see clearly the two waveform. Yeah, single. To find, okay, channel B is the V out. So channel B is the wave for the red color. With the edges until it shows the maximum voltage. So the V out when the frequency is 100 is 1.995 volt, and this is for you. V in, we obtain is 1.99 volt. So for when the frequency is 100, the V out is 1.995 volt. Same goes here. For the time difference is 10.038 milliseconds. So we use this one to calculate for the phase difference. So these are the table for the result we obtained for the RL low pass filter circuits. So frequency is from 100 to 10k. We out we obtain and the phase angle. So these are the readings we obtain. So based on these two table, table 2 and table 2, table 4, we can conclude that when the frequency increases, when the frequency increased, the V out will decrease, but the phase angle will increase. So that's the conclusions, and thank you.